Hi students, we are now discussing question number 6 of paper 1 of JEE Advanced 2022 Physics. So this question says that there is a solid sphere, and on that solid sphere we have exerted two forces which are parallel to each other and which are opposite to each other in direction and at a distance r from the center as shown in the figure. Let me call this force as F and let me call this force as F. So what will happen because of this force? This force will create a torque in anti-clockwise direction, but it will not create any net force. So it will only lead to a torque. Okay. So under these circumstances, the question has clearly mentioned that pure rolling is taking place. Okay, it says it rolls without slipping on a fixed inclined plane, and we need to find the angle, the acceleration of the sphere, the linear acceleration we want to find out. So if we find the angular acceleration, that should do the job for us because the linear acceleration will be equal to alpha into r, and in fact the r is given to be 1. So whatever numerical value of alpha we are going to get, that is going to be the answer. So to calculate the value of alpha, I am planning to write torque equation about this point. To write torque equation about this point, I need two things: the torque about this point and the moment of inertia about this point. The moment of inertia of the solid sphere about this point. Let's calculate them. So when I start calculating torque about point P, what all things do I need to consider? The torque of this couple. So I will write that as I will write that as F into 2R, and that torque will be in anti-clockwise direction. I'm assuming that it is rotating in clockwise direction. So I'm going to put a minus sign here. And then the clockwise torque will be because of the mg sine theta. Like the forces acting on this would be mg sine theta. Actually, I'm drawing the components of mg only. So mg sine theta, mg cos theta. Then a normal force would be there and a friction force would be there. So we can see that friction is not creating any torque, normal is not creating any torque, mg cos theta is not creating any torque, only mg sine theta is creating, and the torque due to the couple will be acting. So the torque due to mg sine theta will be plus mg sine theta into r. So this is going to become the net torque. Let's put the values now. Mass was given to be 1. Here you can see mass is 1. So I'll substitute 1. G is given to be 10. Here it is given as 10. So I'm going to substitute 10. Theta is given to be 30 degree here. So sine theta will become half. Actually, I missed the value of r here. R should also be present here. And r is given to be 1. Okay. Minus f is again given to be 1 and r is given to be 0.5. So this torque becomes equals to 5 minus 1, that is equals to 4 Newton meter. So that is the value of torque. Now we need to calculate the value of moment of inertia. So to calculate that, I'm going to rely on the parallel axis theorem, which is ICM plus MR square. That should do the job. ICM will be 2 by 5 MR square, and this the parallel axis term will be mr square. So this gives us 7 by 5 mr square. And if I now substitute the numerical value of mass, that is 1, radius, that is again 1, so we end up actually this is 7 by 5, guys. So we end up getting 7 by 5 kg meter square. Now alpha will be the ratio of the torque and the moment of inertia. So let's substitute the numbers. So 4 divided by 7 by 5. So this turns out to be 20 by 7, which on doing calculation turns out to be 0.86 radian per second square, and a is nothing but alpha into r. So it is again same as this only, as r is 1. So the answer to this question would be 2.86. Hope you enjoyed the solution, students. Take care. Bye bye.